Welcome to this tutorial of Mesh2Surface for SOLIDWORKS. In this tutorial we'll go through the process of extracting primitives. In this example I loaded a part which is already properly aligned. As you can see, the origin is in the right position. I'll place it for the user to take a look at the orientation of the object, and everything is properly set. For this demonstration I will just show the top plane, as we will use it for some constraints. And let's start. The primitive menu is in our command bar, and it is enabled if we have our mesh selected. So I can go to the primitives. Because we don't have anything selected, the software automatically starts the mesh selection submenu, where you can select your areas of interest. You can learn more about the mesh selection in our other tutorial. Let's try now with a very simple example to take this plane on the top, and that I want to extract this as a plane. I'll use my selection tools and will click on the mesh, and the software automatically will select based on the curvature. Next step I need to do is just press on the icon which is for fit a best plane. What happens now is that the software uses algorithms to find the best fit through the points that belong to the selected triangles. You can see the result on the screen shaded as a plane, and also you can always apply a deviation analyzer. I will just turn this on, and in my case I will just play with let's say 20 microns to see the quality of my approximation. As you can see, it turns out that the plane is not perfectly manufactured. This can be for two reasons. One can be because of the original surface is not perfectly flat, or the scanner has some noise when it has scanned. But in this example, because it's distributed in a different islands, it's more about the quality of the surface. So we have our plane now defined, and we can start using it. But let's think a little bit about the design intent. The design intent is that actually this plane is at a certain position offset from my top plane. In this case, Mesh2Surface can help you to actually constrain, which means to give an extra additional constraint how this plane is reconstructed. Currently, it's the best fit plane, which means that it's positioned in the space in such a way that it approximates in the best way the point, but this is not what we want. For this reason, we can just select an entity that will constrain our algorithm. I clicked on the top plane, which told the software that the algorithms should keep the orientation of the plane exactly the same like my top plane, but then try to approximate. As you can see now, we get something more as an information. It turns out that this plane is not actually perfectly parallel to my top plane. And as you can see, it's right on one side and on the other, which means that the actual scan data are a little bit tilted. During the process of reverse engineering, you constantly will face such a situation, so it's up to the designer to decide which one of the results is better for these purposes. In my example, I want to keep my plane parallel to my top plane, so that's why I will leave it as it is now. So I have three options now. One is that I can create it as a reference only. What this will do in SOLIDWORKS, we will only create reference geometry. It's not a surface, or it's not a solid. The solid option doesn't apply for the plane because there is no solid information here, but you can create this as a surface. This is useful when you model and if you want to extrude up to the surface to use this surface, or you can just leave it as a reference. If I just click create as a reference, the software will create the reference plane, but it will stay in this mode. Why? Because when we want to create alignment or we quickly want to extract a lot of reference geometry, it's good if we still stay here. For example, I can just come and unselect and take my cylinder here. I can feed a cylinder, extract, etc. But I will just press OK now and see what happens with this plane. If I edit this plane, it's just a normal SOLIDWORKS feature. As you can see, it's offset from the top plane at a specific amount. You can modify this and adjust exactly where this plane should be. So this is how we extract the reference geometries. I'll go back again to primitives. In a similar way, you can just use your selection tools. You can pick this surface and then you can define that this is a sphere. Again, you have an option here how to create this in SOLIDWORKS. If you want only the center point to be used for the reference, or if you want this to be as a solid, for example. If I create this as a solid, the software creates this as a solid body in SOLIDWORKS. And as you can see here, this is my solid, and I have it as a solid body which is revolved, because this is how we define a sphere. Let's go through the other features, and I'll go in primitives mode. And in this case, I'll take my cone here and will create my cone. I can see the deviation, how close I am to the surface. And again, I can create this as a surface or as a solid. Let's create this as a surface now, just for a demonstration. You see that the software created the surface revolve in this case, but also it creates the reference axis. This is an important information which I will use now for my next step. For example, I want to get this cylinder. Again, I'll pick the mesh, go to primitives, and this time I will select this area, which is my cylinder. I will click to fit the cylinder. Now it uses all the points to create the best fit of the cylinder, but I'll have a question now: how well this axis is defined? Is it super perpendicular to the top plane? Because in engineering you must have a strict perpendicularity, so it's up for the user to choose. But how we can constrain this is by using, for example, an axis. In this example, I use this axis, and what it does, if we fit a cylinder or a cone, it uses the axis only to constrain the orientation of the cylinder. What this means is that in this example, the cylinder is fit through the points, but its axis is strictly parallel to my axis too. There is a checkbox here, which is in other examples you may get when you have two coincident cylinders or cones. And in this case, what you want to do is just to tell the software that do your best to fit through the points, but I want that my axis to be coincidence with my given axis, which in these examples doesn't give expected results, but everything is correct because it complies with the expectations. It goes through the axis of the cylinder, goes through this axis, but at the same time it fits the selected points, and that's why we get this result. So this is not the case for me. What I need to do now is just use this parallelism of the two axes, and then I can probably create this as a solid. Before that, I can evaluate with my analyzer tool the quality of my best fit. As you can see, the software quickly provides you with the color map of the deviation and gives you information how many points are in tolerance of the selected points. So you can get this information and you can decide if this is acceptable for you. When you're ready, you can just press create and the software will create the solid body for you in SOLIDWORKS environment. More or less, this is all about the basic primitives. I hope this is useful for your project. Thank you for watching.